Good afternoon, everyone. Today we're going to look at a quicker problem where we have a parabola defined by the function y is equal to negative 1/2 times x minus 3 all squared plus 2, i.e. A quadratic function in vertex form, right, where we can read off the vertex being at positive 3 and positive 2. So we have our vertex at the point 3, 2, and we're looking for the two roots, if there are two roots, and its y-intercept. So, to find two roots, we know what we have to first do. We have to set the y is equal to 0, right? That's a standard strategy to find any x-intercepts. So let's go ahead and do that. If y is equal to 0, then we have y0 rather is equal to negative 1/2 bracket x minus 3 all squared plus 2, right? Now, we're solving for x. Our goal is to isolate this x that's bunched up in here, right? And so, to do that, we can first get rid of this plus 2, right? So we can, I'll use a different color. We can first subtract 2 on both sides, meaning that this will become negative 2, okay? And now the goal is to get to this center, this x in the very center of this big term, right? And so we have the x minus 3 that is all squared. The squared does not affect the negative 1/2 up front. So to get rid of that negative 1/2, we can simply multiply this whole thing by negative 2, right? Knowing that negative 1/2 times negative 2 will cancel out, and we always do the same thing on both sides. So we're multiplying both sides by negative 2 to cancel out the negative 1/2 in front, okay? Now negative 2 times negative 2 is positive 4, is now equal to x minus 3 all squared, okay? And now we want to get rid of the square, and so of course we take the square root for the root sides. When we take the square root of a value, like we're doing here, please be mindful of the positive and the negative values, right? And so we're left with x minus 3 because the square and the square root of the right-hand side cancel out, and we have positive or negative the square root of 4, meaning that x minus 3 is equal to positive or negative 2. Now, we can finish that off by adding 3 to both sides, and so we get x is equal to 3 plus or minus 2, which means that x is equal to 3 minus 2 is 1, or x is equal to 3 plus 2 being 5, okay? So we know that our two x-intercepts rather, are at 1 and 0, and at 5 and 0. Now what I wanted to go through in this example is that there are two ways that we can find the roots, right? This is one way, where we're simply setting the y equal to 0, which is standard for any time we're looking for the x-intercepts, and then we're going to do an algebraic strategy to solve for x. That works. Another thing we could do is we could expand this big square to start, and we could actually write this thing in standard form. Maybe that's something that you're more familiar with, and maybe that's something that you find more straightforward. So I just wanted to show the option. So if we have y is equal to negative 1/2 times x minus 3 all squared plus 2, we can start by expanding the x minus 3 all squared. I'll remind you, x minus 3 all squared means x minus 3 times itself. And so the result of x minus 3 in brackets squared is going to be, and you can do this on your own as an exercise, it's going to be x squared minus 6x plus 9. And then we still have the plus 2 hanging around at the end. And now we can go through this. So we have negative 1/2 that's multiplying everything inside of this bracket, this trinomial. And so that means negative 1/2 x squared, negative 1/2 times negative 6x is plus 3x. Negative 1/2 plus 9 is minus, I'll say minus 9 over 2. And then we have plus 2, okay? And now we can simplify this a tiny bit. So we have negative 1/2 x squared plus 3x. Negative number 2 is the same as 4 over 2, if you want to think of it that way. And now we have a common bit on there, and so we can combine those two. Negative 9 plus 4 means minus 5 over 2. So this is our quadratic function in standard form, right? Where our a value would be -1/2, b is 3, and c, the constant term, would be at -5 over 2. This is really useful because we're also looking at the end for the y-intercept, right? And you know that anytime you have your quadratic function written in standard form, that constant term at the end tells you where your y-intercept is at, right? Let's get that one done. So the y-intercept, right away, we can tell is going to be at any y-intercept has an x-coordinate of 0, right? By definition of being on the y-axis. And now we know that c value, that constant term at the end, is going to be the y-intercept's y-coordinate, and so negative. We're putting it on a graph, so 5 divided by 2 is 2.5, so I'll make it -2.5, like so. Okay, so there lies our y-intercept. And now, if you want to find the roots from this point here, now we're still going to rely on the fact that any root is found by making y equal 0. So we're looking at the roots, which means you set y is equal to 0, and you plug it in for the y. But now, what we have is 0 is equal to your quadratic equation written in standard form. And again, maybe that's more familiar and straightforward for you to work with. And so you have -1/2 x squared plus 3x minus 5 over 2. Okay? Now, since we have an equation that have denominators, both being 2, convenient, and it's equal to 0, we can make our life a lot easier by getting rid of these denominators. Okay? I'll also go through the hassle of getting rid of the negative in front of x squared, because then that'll just leave 1x squared, which means we can just factor normally without having to deal with a decomposition strategy. So what I'll do is I'll multiply everything on the right-hand side by -2. Okay? And we always do the same thing on both sides, but the reason why this doesn't cause us, excuse me, the reason why this doesn't cause us any grief is because 0 times -2 is still 0. So we now have 0 is equal to, but the right-hand side has gotten a lot simpler to work with. -1/2 times -2 is just 1x squared. What a relief. 3x times -2 means -6x, and then minus 5 over 2 times -2. Negative times negative is a plus. The 2's cancel out, and so all we have is 0 is equal to x squared minus 6x plus 5, and that's a pretty straightforward quadratic equation to solve by factoring, right? What two numbers add to make -6 and simultaneously multiply to make +5. I'll let you go through that in your head, but you'll find those numbers are -5 and -1. And now by the null-factor law, we know that if 0 is equal to this times that, then either x minus 5 is equal to 0, which would imply that x is equal to 5, or x minus 1 is equal to 0, which would imply that x is equal to 1. And so we find the exact same two values for the x coordinates of our roots, and so we still found that our two roots were found at 1, 0 and 5, 0. Okay? So I really like this first strategy if you're comfortable with the algebra, kind of no matter what we start off with. This is great for an exercise in algebra. But if you're more familiar with converting it to standard form, the standard form does let you read off the y-intercept readily, and then you can kind of go a more, how would you say, typical route of factoring your quadratic function in standard form and getting your x-intercepts in that way. So nice to have some options, nice to have a way to kind of verify your work on an assessment. I hope this helps. I hope you're starting to connect some of the dots in this unit, and thanks for watching.